Right now, somewhere on Earth, a parent is holding a baby who cannot understand a single word of any human language, and they are singing to it anyway. Not talking, not explaining, singing, a wordless up and down melody that the baby cannot parse as language, but responds to instantly, calming down, locking eyes, sometimes falling asleep mid-cry. This happens in every culture that has ever been studied. It happened before written history. It probably happened before spoken history. And here's the part that should stop you cold. From a pure survival of the fittest standpoint, singing makes almost no sense. It burns calories you could be spending on foraging. It makes noise that can attract predators from long distances. It produces zero food, zero shelter, zero warmth. If evolution is a ruthless accountant that cuts anything that doesn't pay for itself, singing should have been deleted from our species hundreds of thousands of years ago. It wasn't deleted. It went the opposite direction. It became universal. Every documented human culture, isolated Amazonian tribes, Arctic hunter-gatherers, ancient civilizations with no contact with each other whatsoever, independently developed singing. Not just noise-making, structured, pitched, rhythmic, repeated vocalization. That level of universality is not a coincidence. In biology, when something this costly shows up in every population independently, it means it's doing something important enough to be worth the cost. The question this video is going to answer is what? And the answer is going to take us somewhere most people don't expect. Because the leading scientific theory today is not that singing came after language, a decorative extra we added once we already had words. The leading theory is that singing came before language, that melody, pitch, and rhythm were the original communication system, and that spoken language, the thing you're using right now to understand this sentence, may have evolved out of song, not the other way around. Let's go through it properly. Start with a name you may not know, Stephen Mithun, an archaeologist whose research popularized what's now called the musical proto-language hypothesis, though the core idea actually traces back further to Charles Darwin himself. In The Descent of Man, Darwin proposed that the vocal organs of our ancestors were used for the production of musical tones and rhythms before humans acquired the power of expressing mutual love in articulate language. Darwin thought singing came first. For over a century, this was treated as an interesting footnote. Then genetics, neuroscience, and comparative primatology started producing evidence that made it look less like a footnote and more like the main text. Here's the core problem the proto-language hypothesis is trying to solve. Spoken language requires an enormous amount of infrastructure to be useful. Grammar, syntax, a shared vocabulary of arbitrary symbols where the word tree has to mean the same thing to both speaker and listener. That's an incredibly high bar. You can't invent full grammatical language overnight, and you can't use half of it, because half a grammar communicates almost nothing precise. But pitch, rhythm, and melody don't have that problem. A rising pitch that sounds urgent is urgent to almost any listener, human or otherwise, without anyone agreeing on a definition first. A low, slow, descending tone sounds calming without a dictionary. This is what researchers call iconic or motivated signaling, where the sound itself carries the meaning through its acoustic properties, not through arbitrary agreement. That's a communication system you can bootstrap with no prior shared language at all. That's a communication system evolution could actually build gradually. So the hypothesis goes like this. Early hominins, long before Homo sapiens, developed a system of expressive, musical vocalization, what researchers sometimes call communication. Holistic, manipulative, multimodal, musical, and mimetic. Whole emotional messages delivered as a single melodic unit, not broken into words. Over hundreds of thousands of years, under selective pressure to communicate more specific information. That musical system gradually differentiated. Certain melodic patterns became associated with certain specific meanings. Those patterns fragmented into smaller reusable units. Those units became something very close to what we'd now call words. Song didn't get replaced by language. Song got dissected into language, while still keeping a working, wordless copy of itself around for everything language is bad at: emotion, bonding, and states that don't reduce well to facts. This isn't just armchair theorizing. There's real comparative evidence in our closest relatives. Gibbons, small apes found across Southeast Asia, produce elaborate, structured, pitched vocal sequences that researchers genuinely call songs. Mated gibbon pairs perform coordinated duets, precisely timed, with each partner contributing specific phrases used to maintain pair bonds and mark territory. This isn't random hooting. It's structured, learned, and rehearsed. Now, gibbons are not our direct ancestors, but they diverged from the primate line that eventually led to humans millions of years before chimpanzees did, which means whatever produced song-like behavior in gibbons was likely present, in some form, deep in the shared ancestry of many primates, including ours. If distant cousins on the primate family tree independently rely on structured melodic vocalization for bonding and territory, that's strong circumstantial evidence that the raw biological hardware for musicality is ancient, not something humans invented from nothing, something we inherited and then dramatically expanded. There's also the FOXP2 gene, which gets mentioned constantly in discussions of language evolution, because mutations in it cause severe speech and language disorders in humans. What gets mentioned less often is that FOXP2 is also directly involved in vocal learning in songbirds. Zebra finches with FOXP2 disrupted can't properly learn their songs from adult tutors. The same genetic machinery that's implicated in human speech is implicated in animal song learning. That's not proof the two are the same system, but it is a striking overlap that fits the idea of a shared evolutionary root between musical and linguistic vocal control. So the biology suggests deep roots. What about the physical evidence? This is where it gets genuinely exciting, because ancient humans, and even non-human hominins, left behind direct, physical proof that they were making music, tens of thousands of years before anyone wrote anything down. The oldest confirmed musical instruments ever found are bone and ivory flutes discovered in caves in southern Germany, at sites like Hohlefels and Geissenklosterle. They're carved from bird bone and mammoth ivory, with precisely spaced finger holes, and they date to approximately 40,000 years ago. Someone sat down, tens of thousands of years before agriculture, before writing, before permanent settlements, and engineered a wind instrument with deliberately tuned finger hole spacing. That's not accidental noise. That's acoustic engineering. But here's where it gets even more interesting, and considerably more controversial. There's another object, found in a cave called Divje Babe in modern-day Slovenia, known as the Neanderthal flute. It's a piece of young cave bear femur, with a row of holes punched through it, dated to somewhere between 40,000 and 60,000 years ago, potentially old enough to have been made by Neanderthals, not modern humans at all. Some researchers argue the holes are natural, made by a hyena's teeth gnawing the bone. Other researchers, running detailed spacing and acoustic analysis, argue the hole spacing matches a diatonic musical scale far too precisely to be an accident of predator bite marks. The debate is still unresolved. But if it holds up, it means our closest extinct relatives, a completely separate hominin species, were making tuned musical instruments too. There's a second, independent line of physical evidence that's arguably even stronger, and it doesn't rely on a single controversial object. It comes from the hyoid bone. That's the small, U-shaped bone in your throat that anchors your tongue and larynx muscles, the physical structure that makes fine vocal control possible. In 1989, a Neanderthal hyoid bone was discovered at Kibara Cave in Israel, and it is, essentially, anatomically indistinguishable from a modern human hyoid. That tells us Neanderthals very likely possessed the physical vocal apparatus needed for the kind of nuanced pitch and tone control that both speech and singing require. One more piece of evidence, and this one is about the spaces ancient humans chose to make music in. Researchers studying decorated Paleolithic caves in France and Spain, places like Lascaux and Arcy-sur-Cour, have found something remarkable when they map the acoustic properties of these caves. The sections with the densest, most elaborate painted artwork consistently correlate with the sections that produce the strongest sound resonance and echo. Some researchers, working in what's now called archaeoacoustics, argue this isn't coincidence. Ancient humans appear to have deliberately chosen to paint and likely to chant, sing, or perform ritual sound, specifically in the acoustic sweet spots of these caves. Painted animals and resonant acoustics next to each other, over and over, across multiple independent sites. That's the kind of pattern that doesn't happen by chance. It suggests sound and image were part of the same ritual system, tens of thousands of years before anyone had a word for either art or music. Now let's come back to that parent humming to a baby, because there's a specific, controlled scientific detective story here worth walking through. Researchers studying infant-directed singing, sometimes just called motherese when it's spoken and extended into song when it's sung, have compared lullabies collected from dozens of unrelated cultures with no shared linguistic or musical tradition. Cultures that never had contact with each other. And they found something striking. Lullabies across the world, independently, tend to share specific acoustic fingerprints. Slow tempo, descending pitch contours, meaning the melody tends to fall rather than rise, and simple repetitive structure. A 2021 study published by a large international team of researchers using thousands of song recordings and listener ratings from participants across many countries found that people can reliably identify a lullaby as a lullaby versus a dance song or healing song from the same culture, purely from the acoustic features, even when they have zero knowledge of the language or culture it came from. That's a genuinely remarkable result. It means there is something close to a universal acoustic signature, for this song is meant to calm an infant, built into how humans everywhere independently compose music. Why would that be? Infants can't understand language for the first year or more of life. They cannot process syntax, grammar, or vocabulary, but newborns can process pitch, rhythm, and prosody, the melodic contour of vocalization, almost immediately. Research on fetal hearing has shown that a developing fetus can detect the rhythm and tonal pattern of the mother's voice through amniotic fluid in the final trimester of pregnancy, well before birth. That means song-like vocal patterns are literally the very first communication channel a human being is ever exposed to, before language exists for them at all, and arguably before language existed for our species at all. Ontogeny, the development of the individual, may be echoing phylogeny, the development of the species. And this connects directly back to survival. A pre-verbal infant who can be calmed quickly is an infant who cries less, which matters enormously for a species where crying attracts predators and where an exhausted, sleep-deprived caregiver is a caregiver who makes worse decisions. A caregiver equipped with an effective, instinctive tool, singing, for regulating an infant's emotional state without needing shared language, has a genuine survival advantage. This is one of the clearest places where singing stops being a mysterious luxury and starts looking like functional biological technology. But infant care doesn't explain the whole picture, because humans don't just sing to babies. We sing in groups, in ritual, at war, at funerals, at celebrations, completely independent of infant care. So there has to be a second major function at work, and the leading explanation researchers point to is social bonding at scale. Here's the underlying mechanism. When people sing together, especially in synchronized rhythm, their bodies do something measurable. Studies on group singing and chanting have found synchronized changes in heart rate variability between participants, along with the release of endorphins and oxytocin, the same neurochemicals involved in social bonding, trust, and pain tolerance. Robin Dunbar, the anthropologist famous for his research on primate social bonding through grooming, has specifically proposed that group music making may have evolved partly as a way to extend social bonding beyond the practical limits of one-on-one physical grooming. This matters because grooming, picking through fur, physically bonding one individual to another at a time, doesn't scale. It works fine for small primate troops, but it becomes physically impossible to maintain social bonds this way once group size grows past a certain point. There simply aren't enough hours in the day to groom everyone individually in a group of 50 or 100 people. Group singing solves this scaling problem elegantly. One synchronized singing session can chemically and socially bond dozens of people simultaneously, in the same amount of time it would take to groom just one or two. There's also a competitive, between-group angle to this, sometimes called the credible signaling theory. A large group that can produce tight, synchronized, coordinated song is broadcasting something real to any rival group listening from a distance. We are numerous. We are organized. We can act as one unit. That's a genuinely useful deterrent signal in a world without written communication, without flags, without any other reliable way to advertise group cohesion and strength from far away. A ragged, uncoordinated group cannot produce tight, synchronized song. A well-organized, cooperative, trusting group can. Singing became a costly, honest signal of exactly the qualities that make a group dangerous to attack and valuable to ally with. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content, covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. Now let's talk about a third theory. One Darwin himself actually favored more strongly than the language origin idea: sexual selection. Darwin looked at male birdsong, elaborate, energetically expensive, often dangerous because it attracts predators as well as mates, and noted that it exists almost entirely to advertise fitness to potential partners. He proposed that early human musicality may have served a similar function: an honest, hard-to-fake display of health, breath control, cognitive complexity, and creative capacity. The logic of this theory rests on what's called a costly signal. Singing well, holding pitch accurately, maintaining rhythm, remembering and improvising complex melodic sequences requires real neurological and physical resources. It's genuinely hard to fake convincingly. That difficulty is exactly what makes it valuable as a signal. Just like a peacock's tail is a costly, hard-to-fake signal of underlying genetic quality, because a weak or sick peacock simply cannot grow and maintain such an elaborate display, skilled singing may have functioned as a similarly reliable, hard-to-counterfeit signal of a potential mate's cognitive and physical fitness among early humans. This theory doesn't have to compete with the bonding theory or the proto-language theory. Most researchers today think these functions likely reinforced each other rather than replacing one another. A trait doesn't need exactly one evolutionary explanation to survive. Singing may have simultaneously helped infants calm down, helped groups bond and signal strength, and helped individuals attract mates. 3 separate selective pressures, all pushing in the same direction, all making singing more likely to persist and intensify across generations, rather than disappear. Here's a detective-style question worth pausing on. Why does music, specifically, produce such a powerful emotional response in the brain, more so in many cases than plain speech describing the exact same content? Neuroscience has a genuinely fascinating partial answer, and it circles right back to the idea that musical processing may be older, evolutionarily, than language processing. Language processing in most people is heavily concentrated in specific, relatively localized regions, primarily in the left hemisphere, in areas known as Broca's area and Wernicke's area. Music processing, by contrast, is far more distributed. It engages both hemispheres, and it activates deep, ancient structures involved in emotion and reward, including the amygdala and the brain's dopamine-driven reward circuitry, the same reward pathway activated by food and by addictive substances. This is part of why a familiar song can trigger a genuine, measurable dopamine release, sometimes referred to informally as chills or skin orgasms in the research literature, in a way that reading the same words as plain text typically does not. There's also striking clinical evidence for music sitting on a separate, more resilient neural track than language. Patients with severe non-fluent aphasia, a condition often caused by stroke or brain injury that devastates a person's ability to produce ordinary speech, can sometimes still sing entire familiar songs, correctly, fluently, word for word, even though they cannot speak the same words in conversation. This is the basis of a real clinical technique called melodic intonation therapy, where speech-language pathologists use singing as a bridge to help stroke patients gradually recover functional speech. If music genuinely runs on older, more distributed, more resilient neural circuitry than language, and the clinical evidence strongly suggests it does, that fits precisely with the idea that musicality came first, evolutionarily, and language was built partly on top of it later, layered over an already existing system rather than starting from nothing. So if musical, melodic vocalization really did come first, how do we actually get from wordless melody to full grammatical language? This is the part of the theory researchers are still actively refining, but the general model looks something like a gradual segmentation process. Early holistic musical calls, whole emotional or situational messages delivered as one unbroken melodic phrase, slowly began to be broken down by the brain's pattern recognition systems into smaller, reusable chunks. A chunk that reliably showed up whenever danger was present eventually became reusable in other combinations. Reusable, recombinable chunks are, functionally, the earliest possible form of words. Once you have reusable chunks, you get combinatorial power almost for free. A small number of reusable sound units can be rearranged into an enormous number of distinct messages, which is exactly the property that makes human language so extraordinarily expressive compared to the fixed, non-recombinable alarm calls of most other animals. Rhythm, meanwhile, likely provided the scaffolding for grammar itself. The strict timing patterns already present in musical rhythm may have provided the cognitive template for sequencing, for understanding that word order and structure carry meaning, an insight modern linguists consider absolutely foundational to how grammar works. Under this model, language didn't replace song. Language is, in a very real sense, song's more specialized, more precise descendant, optimized specifically for transmitting exact factual information, while the original, more holistic musical system was retained, essentially untouched, running in parallel, specifically because it remained better at everything language is still bad at today, conveying emotional nuance, synchronizing group feeling, and communicating with people, especially infants, who don't yet share your vocabulary. Now, in the interest of being straight with you, it's worth being honest about where this theory is genuinely solid and where it's still actively debated, because a responsible account of this topic has to hold both at once. The musical proto-language hypothesis is well supported by comparative primatology, by the FOXP2 overlap, by the hyoid bone anatomy, by the universal acoustic signature of lullabies, and by the clinical neuroscience of music versus speech in aphasia patients. That's a genuinely strong, multidisciplinary convergence of evidence. What's still genuinely contested is the fine detail. Exactly how a musical proto-language fragmented into grammatical language, exactly when in the roughly 6 million year hominin lineage this transition occurred, and whether the Neanderthal flute from Divya Babe is a genuine instrument or a hyena's leftover dinner, are all live unresolved questions among specialists. Some researchers favor gesture-first theories of language origin instead of song-first theories. Some think music and language co-evolved together from the start, rather than one clearly preceding the other. The honest position is that the song-first hypothesis is currently one of the best supported theories, not a settled, unanimous fact. So let's pull this all the way back together. Singing looks, on the surface, like a strange evolutionary indulgence. Costly, calorically expensive, acoustically dangerous, with no direct nutritional or defensive payoff. But every piece of evidence we've walked through today points toward the same underlying conclusion. Singing wasn't a decoration added onto human life after the important survival work was already done. Singing may have been part of the original survival toolkit itself. It calmed pre-verbal infants when nothing else could reach them. It bonded groups far larger than one-on-one grooming could ever manage, releasing the same neurochemicals that build trust and cooperation. It broadcast group strength and cohesion to rivals watching from a distance. It very possibly signaled individual fitness to potential mates, the way a peacock's tail does, but built entirely out of sound instead of feathers. And running underneath all of it, deep in the architecture of your own brain right now, is a musical processing system that neuroscientists increasingly believe is older and more resilient than the language system layered on top of it. A system so deeply rooted that a stroke can take away someone's ability to speak and still leave their ability to sing completely intact. Every time you catch yourself humming absent-mindedly while doing the dishes, every time a song gives you chills for no logical reason, every time you find yourself instinctively swaying in rhythm with a group of strangers at a concert, you are running a piece of software that is, by very conservative estimates, tens of thousands of years old, and by some of the evidence we've covered today, possibly far older than our own species. Long before anyone could ask, what does this word mean? Someone, somewhere, already knew exactly what a rising note or a falling one meant. We didn't learn to sing after we learned to talk. There's a real, growing body of evidence that we may have learned to talk because we already knew how to sing.